This is the Ariane 5, a liquid propellant rocket developed by the European Space Agency. Since its first operational flight in 1999, it has successfully completed 117 space missions, transporting large payloads such as satellites and communication equipment into Earth's orbit. In this video, we will take a closer look at the Ariane 5 to explore its various components and understand how they work together to escape from this planet. The Ariane 5 is 167 feet tall and 16 feet wide. To put that into perspective, it's about 10 times larger than a family car and generates 10 times more power than an Airbus jet. When fully fueled, it weighs about 1.65 million pounds. Almost 90% of this weight comes from its fuel tanks, while less than 2% is the payload weight. The Ariane 5 is not just one rocket, it is a combination of 4 rockets. It consists of a main stage rocket, an upper stage rocket stacked on top of the main stage, and 2 solid rocket boosters attached to the main stage. Both the main stage and the upper stage are liquid-fueled rockets, while the boosters are solid-fueled rockets. The main difference between liquid-fueled and solid-fueled rockets is how the fuel is stored. In liquid-fueled rockets, hydrogen and oxygen are kept in separate tanks, whereas in solid-fueled rockets, the fuel components are mixed and stored in a single container. Launching a rocket into space requires a tremendous amount of energy. The Ariane 5's main stage engine isn't powerful enough on its own. It needs the help of its 2 solid rocket boosters. Here's how it is launched into space. At 0 seconds, the main engine ignites, and the computers quickly verify that the engine's thrust is building correctly. 7 seconds later, the solid boosters fire up, providing 90% of the initial force needed to lift the Ariane 5 rocket off the ground. The rocket lifts off just 0.3 seconds after the boosters ignite. At 2 minutes and 10 seconds into the flight, the booster rockets run out of fuel. Explosive bolts then detach the boosters from the main rocket, causing them to fall into the ocean. Once the rocket reaches a height where the air is too thin to harm the payload, the nose cone, known as the fairing, is released. The main rocket continues to burn for 10 minutes after launch, using up all its liquid hydrogen and oxygen fuel. After this, the main rocket separates, and the upper stage takes over. The upper stage is the only part of the rocket that did not ignite at launch. It can be restarted after shutting down and can burn for up to 19 minutes. This stage is responsible for placing the satellites into orbit around Earth. Now let's take a look inside the Ariane 5 to see how it works. Let's begin with the solid rocket boosters. These boosters are attached to the sides of the main stage and provide 90% of the thrust during liftoff. Each booster stands 100 feet tall and weighs approximately 610,000 pounds. Inside the booster is a large fuel container filled with powdered aluminum, which serves as fuel, and ammonium perchlorate, which acts as the oxidizer. At the top of the booster is an igniter that initiates the combustion process. At the bottom is the nozzle, which expels hot gases. Solid fuel rockets are simple and powerful. Once ignited, they continuously burn until the fuel is used up and can't be stopped or adjusted. They provide huge amounts of thrust right from the beginning, which is exactly what's needed to escape Earth's gravity. These gases push downward, generating an upward force that helps lift the rocket into the sky. Between the 2 boosters is the main stage, which houses the Vulcain 2 engine at its base. This engine burns liquid hydrogen and liquid oxygen, both stored in large insulated tanks above it. The hydrogen and oxygen are kept as supercooled liquids. Liquid hydrogen is extremely light and must be maintained at temperatures below -253 degrees Celsius. Liquid oxygen, being heavier, is stored at about -183 degrees Celsius. The Vulcain 2 engine pumps these 2 liquids into the combustion chamber, where they mix and ignite, producing high-pressure hot gases. These gases are expelled through the nozzle, generating thrust. Inside the combustion chamber, temperatures can exceed 3,000 degrees Celsius, hot enough to melt any metal. To prevent overheating, the Ariane 5 uses a regenerative cooling system. Liquid hydrogen is circulated around the engine walls first, absorbing heat before it enters the combustion chamber. This method not only keeps the engine cool, but also warms the fuel prior to combustion, making the burn more efficient. Stacked on top of the main stage is the upper stage, which contains another engine designed for space. Unlike the lower stages, it can start and stop multiple times. This flexibility is important for placing satellites into precise orbits. The upper stage engine also runs on liquid hydrogen and oxygen, but the engine is smaller and optimized for use in a vacuum. It can burn for up to 19 minutes. This is the vehicle equipment bay, the brain of Ariane 5. This part of the rocket contains the guidance computer, which constantly tracks the rocket's location, speed, and direction. It uses laser gyroscopes to detect even the smallest changes in angle. If the rocket drifts off course, the guidance computer adjusts the direction of the nozzles using gimbals. This shifts the thrust and steers the rocket back on path. This is the fairing, the protective shell around the satellites. It is made of carbon fiber and designed to protect the satellites from heat, sound, and vibration during launch. It's about 5.4 meters wide at its base, large enough to park a car inside. Ariane 5 carries up to 2 satellites, which are housed inside the fairing. That's how the Ariane 5 works. If you enjoy this video and wish to support our small channel, please subscribe and click the notification button. Thank you for watching.